I'm Robert with AWS, and we're going to talk about migrating .NET frameworks to the cloud. Quick bit of introduction. I've been at AWS for the past year and a half. Prior to joining AWS, I was a software engineer on the GraphQL team at Facebook. And prior to that, I was a software engineer at Microsoft, where I worked on the .NET framework, Windows Server, Xbox Game Studios, and the Startup Business Group. So .NET is very near and dear to me. Can I see a show of hands? How many people here consider themselves .NET developers? Okay, that's nearly everyone. IT leaders? All right, ops, sysadmins? Yeah, okay, so I'm in good company. This is going to be awesome. Here's the agenda. I'm going to give you an overview of the tooling that we have for .NET developers on AWS. Oh. Thank you very much. We had the wrong video input. All right, so I'm going to give you an overview of the tooling that we have for .NET developers on AWS. We're going to focus on one service in particular, Elastic Beanstalk. We're going to talk about why that service can make your life easier when you're migrating .NET framework applications to the cloud. We're going to migrate a sample application. And before we migrate it, I'm going to show you the sample application because, as you well know, the migration, when you're migrating applications, it's not .NET that's the problem, right? It's the entire stack around it that you're going to need to migrate together. The database, right? The web server, the OS. That's what makes it difficult. So we're going to talk about all of that. And then we're going to migrate this application step by step. And after we've migrated it, we're going to revisit how we administer that application, because the administration workflow is just as important, right? And then I will finish with a bunch of troubleshooting steps, because everybody knows that when you watch these tutorials online or you watch somebody go through it for, and they know exactly what to do and exactly what to do in the console, that's not the experience you're going to have. You might make some mistakes. And so I want to show you how to fix those mistakes. Sound good? Let's do it. So, as an aside, the definition of the .NET framework these days is a little bit muddled. The .NET standard is a little kind of a mess, I think. And what we're going to talk about today is the old school .NET framework for Windows, the full .NET framework. Now, .NET Core, Xamarin, Mono, these are all excellent libraries, implementations of the .NET framework. But it's beyond the scope of this talk to compare and contrast the different variants of .NET framework. We're just going to be focusing on the full .NET framework. There are more .NET workloads on AWS than on any other public cloud provider. And part of the reason is because we have this philosophy at AWS. We want to build the right tool for the job. As a result, we've built a number of tools for .NET developers to help make your lives a little bit easier. I want to go over a couple of these. First, in the top left, we have the AWS Toolkit for Visual Studio. You can download this toolkit, this extension, in the Visual Studio Extension Marketplace. And once you've configured it, you're going to be able to drive all of the most popular AWS services right from within Visual Studio. You never have to leave the comfort of your IDE. We also have a variant of the toolkit for Visual Studio Code, for those of you who are using the portable version of Visual Studio. We have the SDK for .NET with first-class API support for .NET languages. And using the SDK, you can programmatically drive the APIs on AWS. You can also do that from within the command line using the CLI. And of course, all of this integrates with your PowerShell scripts. And just this last year, we announced the CDK. And .NET, C# in particular, is one of the 4 launch languages for the CDK, Cloud Development Kit. Now, the CDK is really cool. You should check this out when you get a chance, because using the CDK, you can use C# to define infrastructure as code, immutable infrastructure as code that compiles down to a CloudFormation template. And then you can check that into source control so that you can have a granular control over the definition of your infrastructure. Very powerful stuff. There's a screenshot of the AWS Toolkit in the Visual Studio Marketplace if you are looking for it. And again, you can use this to manage all the most popular AWS services, whether it's IAM, EC2, S3, SQS, you name it. We'll see more of this shortly. Here's a screenshot of all the different services that it supports. Now I want to talk about Elastic Beanstalk for a bit. Elastic Beanstalk is one of our meta services. And what Elastic Beanstalk can do for you is to help you easily deploy, monitor, and manage 3-tier web applications and services. And it actually supports a whole number of different stacks. It can help you migrate your Go applications, your Ruby applications, your Python applications, your Node.js applications, and of course, your .NET applications. And the core value proposition of Beanstalk is going to start to sound very familiar to you. We want to reduce the amount of undifferentiated heavy lifting that you do. And in layman's terms, that just means we want you to spend your time on the thing that makes your business special. Because we believe that installing and configuring Windows, adding service packs, downloading the .NET framework, installing and configuring IIS, these are not the things that make your business special. Probably not. And so if you think about that set of activities, you have to do all that stuff in EC2 if you want to get started with migrating your application to AWS. And that's only for one server, so it could be hours before you're up and running. And then if you want to scale out horizontally, you want to manage a cluster of these, that's a repetitive task that you have to do over and over. That's exactly what we mean when we say we want to automate that so that there's a lower risk of error and everything goes a little faster and you have a reproducible environment. The other benefit that Elastic Beanstalk gives you is that it can create an auto-scaling group for you. So that if your application outgrows a single machine, we can stamp out clones of it to serve more traffic. And as we'll also see shortly, it's quite simple to hook it up to a relational database backend and then have your application talking to a database that lives in the cloud. Now the demo I'm about to show you lives at this URL. Don't worry about taking a picture of this or anything. All these slides will be sent out to you if you scan your badge, so you can consume this on your own time. I think you'll get the most out of this presentation if you just follow along. If you're wondering what my development environment looks like, these are the main pieces. I have Visual Studio 2019 Community Edition, although the toolkit that I'm about to show you will work with any version of Visual Studio 2017 or 2019. I'm also using SQL Server Express 2017, and then I'm managing that with SQL Server Management Studio 2018. Now I know this is not the exact setup for all of you, but I hope this approximates what some of you have dealt with in your day-to-day development tasks. So I have my application loaded in here. And again, this is an ASP.NET web application. It's a web forms application, not an ASP.NET Razor application, not an ASP.NET MVC application. Web forms. And there's a specific reason why I chose web forms. I chose web forms because, this is a technology that is a real workhorse, right? It's battle tested. It works at scale. We know exactly how to deploy it and administer it. And while, sure, there are some things about it that we would like to improve, and there's things that we want to improve about every framework. What I want to emphasize here is that you're going to hear a lot of noise about using the latest and greatest thing, modernize, modernize, modernize. If this is the thing that gets you productive, if this is the thing that your team knows how to use, then don't feel bad about using it. It feels strange to have to say that, but I feel like people need reassurance that using technology that's proven and time-tested is a good idea. The other thing is that this stack is just incredibly productive. I've combined this here with Entity Framework. How many people here have used Entity Framework? Okay, that's a good number of you. Entity Framework, for those of you who haven't heard of it, is an object relational modeling framework. It's the most popular ORM in the .NET ecosystem. And with this ORM, we can basically write code first and then apply a couple of attributes and have it generate the database schema, therefore giving us maximum productivity. An ORM is not a silver bullet. It will not solve all problems in all situations, but for a lot of simple CRUD apps, it's the fastest way to get up and running and not get bogged down in the details of designing your database schema or choosing a database or anything like that. Okay? So let me show you the application that we're going to migrate. It's a mailing list manager, and this is, again, built with ASP.NET Web Forms 4.5. And there are two key entities in this application, lists and users. And the idea is, let's say I want to manage different mailing lists, different subscriptions inside my organization. I might have a list of users here. These are all users that were created with some seed data. But I can add users and lists, and I can add a new list here. Let's say I can click Create, and then I now have a new list down below. I can click into details here. I can see that it's a brand new list. It has no subscribers. That shouldn't surprise you. I can click Users, and I can say, add user, and then I can click on this user, and I can subscribe Tony to all of these mailing lists here in my application. And then now if I go back into the lists, and I click the Avengers, I see that Tony is now part of this mailing list. That's all it does, right? Pretty simple application, I hope you agree. Now let's take a look at how this thing was built and what we might need to do to migrate it. Oh, actually, before I do that, let me show you what it looks like to administer this application. So this is writing to SQL Server Express 2017 running on my machine, right? I've connected, so let me get this thing into a fresh state. I can administer this SQL Server instance using SQL Server Management Studio. Anybody here use SQL Server Management Studio? Okay, a lot of people. So I can come in here and I can locate my database by expanding database, and all my data is in this mailman database. If I open up tables and I select users, you can see that these are all my users. And if I select mailing lists, this is a, okay. I guess it was cached, had cached something, but we now have all three lists in our database. And just to show you what we can do here, even if our application doesn't support certain operations, we can make edits directly in here. And then if I go and refresh the application, you can see that his name is updated, right, by editing directly in the database. So I can do a lot of administration tasks just like that. The other thing that this thing created for me was this association table, because what we have here, when mailing lists contain users and users contain mailing lists, you have something called the many-to-many relation. And the way that NET framework models the many-to-many relation is by creating an association table for you. And the association table that it's created for me here is called user mailing lists. This is probably going to be unremarkable, but I just wanted to show you in case you were wondering how this association is being done, right? So these are foreign keys into the users and the mailing list tables. Okay? Now let's take a look at the application very briefly. All the UI that you see is, of course, defined in these .aspx pages. These are web forms markup pages. I'm not going to spend a lot of time on that. I want to direct your attention to this models directory. I apologize. I know the text is a little bit small. But in the models directory, we have 5 files. They're all worth going through. So let's start with our model files. This is the user model file. And you can see that, for the most part, it looks like a plain old .NET class. Right? It has ID, first name, last name, email address, and then a list of mailing lists that it has subscribed to. And notice that we have 2 attributes here. for ID. One of them seems to say that it's a key, and the other says that it's database generated. Both of these are entity framework attributes. Similarly, for the mailing list, it looks almost the same. Name, description, subscribers, ID, and then it has the exact same two attributes for ID, telling us that it's going to let the database use an auto-incrementing ID as the value. We also had some initial values in the database, and that came from this database initializer. And this database initializer is a concept in Entity Framework that allows you to plant some seed data when you're dealing with an empty database. This is not so useful in production scale applications, but it's useful when you're running demos, prototypes, and that's what we have here. And so you can see that here I just have a bunch of static collections that I will see the database with in the event that the database does not exist. Then we come into probably the most important class here. This is the mailman DB context. And this derives from the DB context base class, which is, again, an entity framework concept. And here you can see that we have these two, well, in the constructor, we pass in the connection string from the DB config class. We'll take a look at the connection string shortly. The connection string is also critical, but I want to take you through the rest of this file first. We have these two DB sets, and you can think of a DB set as a in-memory representation, but sometimes the in-memory representation of an entire table doesn't fit. So this is kind of a virtualization of it, a handle to the table, right? And using this, you can make local changes, and then you can save those changes and commit them to the database in an atomic way. So you can see that all of the operations that we had in the application, delete list, add new user, create list, etc., these are all extremely simple functions, often with less than 6 lines of code. That makes this code very easy to review, very easy to maintain. And you can see that after we manipulate the local list, and we can use link expressions, by the way, after we manipulate the local representation of the list, we call this save changes function, and then Entity Framework will commit that. And now we haven't dealt with SQL statements at all, right? That's the whole point of the object relational model, is to provide an abstraction over the database so that you are, as much as possible, you are writing application code in the language of the application itself. That way you make fewer mistakes and you're more productive. Okay, and then finally we have the connection string. So this is db config, get connection string, and this is critical because this URL right here, this is where I took this from. And I'll show you what I changed in a moment, but I just want to walk you through this code line by line because one of the most common problems with SQL Server and .NET applications is the connection string, right? You get the connection string wrong, nothing's going to work. So we have to understand what this is actually doing. This is pulling configuration manager.app settings. Now, this is the standard API for a .NET application to access application settings, whether it's in the settings.xml file next to the exe, or whether it's from environment variables. So once we've pulled in the app settings, we're looking for a value with the key RDS-DB name. RDS here stands for Relational Database Service. This is our managed service for a whole bunch of different relational engines, and we'll see more of that shortly. And if this string is empty, then we're going to return a hard-coded connection string pointing to my local SQL Server Express instance. Now, in a real application, it would not look like this. We would not be hard-coding connection strings in the application. This would also come from app settings somewhere, an environment variable. Maybe I call a service to pull the value in. But I'm just doing this for the sake of simplicity. If DB name is not null or empty, then we fall through the else clause, and we start pulling in a couple of other fields that are present, given the fact that this is already present. Namely, username, password, hostname, and port, right? And then we're stuffing this into a string template format, and then we're returning that thing as the string. In other words, this dbconfig file knows how to react based on whether it's running on localhost or whether it's running in the cloud. Because if it's running in the cloud, it can find the correct environment variables and connect to the RDS instance. Okay? Now, I want to show you what happens when we try to deploy this application to the cloud. I already installed the AWS Toolkit. And once it's installed, if you right-click on the project, not the solution, the project, you should see this button appear called Publish to AWS Elastic Beanstalk. If you click it, it will open up the Publish wizard. And inside the Publish wizard, if you haven't done so already, you can specify your AWS credentials. This is your API access key and secret access key. If you already ran the CLI, then this might automatically be populated for you, and you don't have to do anything else. But here you can also select the profile, which then specifies the region. Here we've manually selected the US West region, and I'm using the test profile. And now the first time you come in here, you're not going to have an existing environment. You're going to select Create a New Application Environment. I would show you the Create New Application Environment flow, but there's nothing that exciting, and it takes a couple minutes. It's precious time that we don't have. So I created it before the talk, and I'm going to redeploy. So I'm going to choose Redeploy, and then I click this. I click Next. And then we'll have a number of options, like the build configuration that I want to deploy, the application pool for IIS. Everything is fine here. And then if I click Deploy, it's actually running a deployment now. In fact, what it's doing is it's taking this local application, this .NET application, and it's creating a package, and it's tagging that package with a version, and then it's sending it off to Elastic Beanstalk. And then when Elastic Beanstalk gets it, it's going to perform something called a blue-green deployment. And it's basically going to spin up a machine and deploy all of these, my package onto there, and make sure that that machine is in a clean state that I want. And to show you that that's happening, I'm going to flip over into Elastic Beanstalk, the Elastic Beanstalk UI, click my Mailman application, and you can see that this is actually running right now. That deployment is being processed currently, and I kicked it off from within Visual Studio. So using this UI here, you can watch the deployment status. In case you're wondering how to find Elastic Beanstalk, you can find it in the console using the search field. Right? Let me show you real quick. You just come into the search field and you say Elastic Beanstalk. And you can mix and match all the different ways to do this. You can create the application here first. You can deploy to it. You can create it within Visual Studio and then administer it here, whatever you want. So while this application is going, we know that we want to connect this thing to a database. When the application was running on-premise, it was talking to SQL Server Express. But once the application is deployed into the cloud for the very first time, it's going to return no connection string, or it's going to return the hard-coded SQL Server Express connection string. Only when the EC2 instance running your IIS application tries to use that connection string, it's going to completely fail, because there is no SQL Server Express instance running in the cloud. What we actually want to do is spin up an RDS instance, and then the RDS environment variables will be populated so that the application picks up on that connection string and starts to talk to RDS instead. Right? So the first time you come in here, you need to do this by yourself because it doesn't know what kind of database you need. And in order to create a database, you'll come in here and click Configuration. And then once you click Configuration, you're going to scroll all the way to the bottom, and you won't see anything populated here for database. Again, this is something that I pre-baked for the demo as well because it takes a couple minutes to spin up, and that's precious time. So what you would do here is you would click Modify. You would be taken to a page like this. You would choose your instance class, your database size, and then importantly, your database engine. Okay? Now, there are a number of relational database engines available in RDS. I believe it's MySQL, SQL Server Express, Postgres, and a number of others. You have to choose a matching engine. This is not the time to migrate from one database to another. Okay? One step at a time. Then you also specify your database credentials. And this is usually with username and password. And then you can specify the retention policy for the backup snapshots for your database, and then the availability. Now, for the demo, I have selected delete, which will basically have no retention policy for my database, and I've selected low availability. But when you do this yourself, do not click apply yet at this step. You'll want to click continue, because there's more settings that you have to configure in order for this database to work. So I'm going to take you back to the configuration. After you click continue, you want to click network here, right above the database. You want to click modify, And then down below under database settings, you want to choose 2 availability zones, at least 2, right? In production, the reason why we do this is, so how many people here are familiar with the concept of availability zones? Okay, that's everybody. I'm not going to describe it. Talk to me afterward if you missed it. But we have to choose at least 2 availability zones, even if on the previous page we chose low availability. All right? So this is something that's not going to work if you just like low availability, single AZ. It just won't work. Trust me. And then once you choose these availability zones, then you're good. Just click apply. Once your RDS instance comes up, you'll be able to connect to it using its connection string that is automatically populated in the environment variables for your Beanstalk application. So right now our deployment has completed, and that means our application is up and running. And since I pre-created the database, this is going to work. But if I had no database, then we should see the crash page for the ASP.NET application, right? And there you go. Indeed, my database is working, because if it weren't working, then we wouldn't see this page load at all. Notice that this is a mailman-dev.uswest-2.elasticbeanstalk.com. This is not a domain name that I chose, nor is it protected by SSL TLS. So that's room for improvement right there. You can definitely connect your Elastic Beanstalk applications to a custom domain. You can protect that custom domain with SSL. There's lots of documentation on how to do that, but it's a separate topic, and I'll let you read up on that if that's important to you. Okay, and I'm not going to take you through the application again. It's a pretty boring application. But now that my database is up and running in the cloud, I actually have another problem to solve, right? What does my administration workflow look like? Because before, I had SQL Server Management Studio, and I might have had a team of DBAs, or I might do this myself, but I might want to keep that exact same administration workflow intact. Maybe there are some scripts that I need to run. Maybe there are some things that I need to do that I can only do by directly editing it in the database. And if we come into configuration, and we take a look at the database, this is my database here. Luckily, I have this entry point and port, right? So for those of you who've spent a little bit of time with SQL Server Management Studio, maybe you know the answer. You just grab this endpoint and port, and you come in here and say endpoint, comma, port, and then you connect, right? Well, we need to change this to SQL Server authentication, and then we need to connect using this. And this will work, but you need to take a couple of steps before you do this. When you deploy a database in RDS by default, its public accessibility will be set to no. And this is in accordance with the principle of least privilege. This is a security principle that basically deploys your databases and your applications in the most locked down way by default. And then it forces you to think about what you're opening and how you're opening access to it. So the first thing you need to do is flip public accessibility to yes. Otherwise, at the top level, this RDS instance is not going to allow any connectivity. Okay? The second thing you need to do is you need to come in here into the VPC for this RDS instance. And then you need to take a look at the inbound rules. Actually, this is great, because this is not, let me show you this thing. This is not going to work even though I have public access enabled. Right? It's going to time out, but I'm going to fix it while it's timing out. So in here, in the security group, you can see that there's 2 security group rules here. There's 2 inbound network rules inside this security group. One of them points to this other security group, which is the security group that Elastic Beanstalk created for me to run my application. And so it's saying the application can talk to this database. Indeed, we saw that it had to be able to talk to the database, otherwise it wouldn't have been running, right? But if I want to administer it, then that's a different inbound rule. And I happen to have an inbound rule here, but I scoped the source IP address to a different IP address because I'm on a Wi-Fi network now. So I need to edit this. And now I have the new IP address that I've currently leased on my laptop. This is exactly what we expected to see. Oops. And I'm in. And now all the workflow that I'm used to running with SQL Server Management Studio, I can run against my RDS cloud relational database. Right? So you can see that what this is buying us is we now have all of our resources in the cloud. We have the benefits of running in the cloud. We have the scalability options available to us. We have the security benefits. We have the agility. But we haven't jeopardized any of our workflows. I think that's one of the critical things. Right? Remember in the beginning when I talked about this kind of over-eagerness to modernize the application? You know, often what gets lost in that conversation is, what about our existing workflows? What about the things that run the business today? Well, I think this solution is really powerful because you can keep those exact same workflows. Let's make sure that we can actually. So notice one thing that happened here is that we have a different database name. And let's see if the Wi-Fi networks can cooperate with us. So if I expand tables, I can see that I have the same 3 tables. So Entity Framework is just fine talking to a SQL Server Express instance being managed by RDS. If I choose mailing lists, sorry folks, it's a little bit slow. This is the risk we take with live demos on stage. Yeah. Let's try one more time, and then if that doesn't work, we're going to move on, okay? Yeah. Good old SSMS. All right, I'm just going to give up here. We'll take it back to the slides for now. Wait, did it work? Did it work? Okay, yes. What if we delete this row? And we no longer have the intermediate mailing list. So this is not smoke and mirrors. I don't know if anybody here really doubted me. But I also want to point out another thing that I really like about this stack, by the way, that when you're working with a relational database, you know, for the last 2 decades, we've had this stampede toward NoSQL databases. But look how powerful a relational database can be, right? What just happened here is profound because we deleted this row inside the mailing lists table. But what the database did for us was maintain referential integrity. That means there are no dangling foreign keys pointing to this row that I deleted. If this were in a NoSQL database or a key document store and I deleted a document, I have to go and fix up all of the dangling pointers to that document. And transaction support for NoSQL databases is usually restricted to the document level. DynamoDB is an exception because you can run transactions up to 4 megabytes. But even then, right, you kind of have to have this running tally in the back of your mind. Uh-oh, have I used up my allowance for what the transaction allows? So just kind of underlining the fact that even though this technology is quite old, it's still very powerful. And it still gives you a lot of stuff right out of the box. So if you know, if this is the stack you know, this is the stack you're productive with, don't ever feel bad about using it. All right. Now, I want to walk you through a couple of troubleshooting steps. These are things that you might run into when you're going about this yourself. And the first thing is this. Oh yeah, I wanted to show you this. So inside this URL, when you search for RDS connection string from a .NET application, this is the page that you'll find, right? How do you specify a database connection string? This is our official docs, live. But they parse out the port here, and then they don't actually use the port in the string right here. Okay, so the version that I have is just a quick fix for this. It does include the port. So just be careful about that. Sometimes when you're running on a new dev environment, you might see this error message pop up when you run your ASP.NET application. Something like bin roslyn csc.exe failed. This is nothing to do with AWS. I hope that you believe me there. It just means that the compiler, the .NET compiler, isn't correctly installed. No wonder, I mean, with all the different .NET SDKs and installation tools and frameworks these days, it's easy to get into this situation. If this happens, open up PowerShell or open up the Visual Studio NuGet package manager and run update package down here. If you got a little bit gung-ho and you chose a different SQL database in RDS that didn't match the client, then what you'll have is a client-server mismatch. And if that happens, you'll see this cryptic error state 18. So I repro'd this by deploying a MySQL instance behind RDS and then connecting with a client that expected SQL Server Express. And this is what I got. OK? Another thing I want to mention here is notice that we have a detailed stack trace, right? In order to get the detailed stack trace in an ASP.NET application, by default, it's not going to show you a detailed stack trace at all. This is for security reasons. So if you want to get the detailed stack trace out of an ASP.NET application, you need to come in here into web.config, and then under configuration, system.web, custom errors, mode equals off. You need to make sure that this element is there. Otherwise, you're not going to see a useful stack trace. OK? And then there were several steps that we needed to take in order to make connectivity to RDS possible from SSMS. One of them is to open up the accessibility settings, the top-level accessibility settings for public access for your RDS instance. You have to flip that from no to yes. You have to then go into the VPC. And then for the security group, you need to add an inbound rule. And security group is just a virtual firewall, right? So those of you who've worked with EC2 a lot, you know all about this. But we need to basically enable network connectivity from preferably a scoped source IP address, a well-known IP address, because you definitely don't want to open it up to the world. And then that way anybody can guess your password and you're hosed. You need to use the right management client. So obviously, SSMS is not going to work when you try to connect it to MySQL or Postgres, right? So make sure you use the right management client. And then when you're using the connection string format, sometimes you see documentation that says the connection string format is delimited by a colon. That won't work. You need to use a comma delimiter between the endpoint and the port. Last bit, this wasted me a little bit of time when I was building this demo. I got this cryptic error message, cannot implicitly convert from type X to iQueryable. It took me a little bit of digging, but the reason this happens, this is nothing to do with RDS or AWS or Elastic Beanstalk. This is purely a ASP.NET web forms problem. And this happens when you name the ASPX page the same thing as another class, another model class. So for example, let's say I have a model file that's called mailman.cs, and it contains a class mailman. If I create a mailman view, a web view, then what it's going to do is create a code behind file that is also called mailman. But the problem is because of the order in which the code is generated, it's not as helpful. Usually if you create duplicate names inside a single namespace, the .NET compiler is actually very good at telling you this is an ambiguous name, right? But in this case, it's not because of the code gen process for ASP.NET Forms pages. So if you see this, just double check that you haven't accidentally named one of your web forms pages the same thing as one of your other classes. Okay, and here's the source code. Again, you don't have to copy this down. I'll be sending this out. If you scan your badge, you'll get a copy of the slides, and you can go through this at your own pace. Now, I bet you many of you are wondering, wait a minute, we didn't actually migrate any data. We didn't migrate the database, right? We had to create an RDS database from scratch, and then the database initializer ran and filled it with seed data. But what if I have a bunch of data on premise? How do I get that into the cloud? And that is actually a very complex topic. So that's why we have something called Database Migration Service. And with DMS, you're going to be able to migrate your databases from on-prem to the cloud in a variety of different patterns that have a variety of different trade-offs. So one of the overarching goals of this service is to provide minimum downtime during the migration process. But I don't have time to go into this service, but I think you should check it out if you have a use case where you're trying to migrate the data from on-prem into the cloud, as well as the application. This is an extra slide that I didn't put in there. But that is all I have for you. Thank you very much. I'm going to hang around in case you have any more questions. And if you enjoyed the session, or if you have any feedback at all, please complete the session survey in your mobile application. Thank you very much.